This video is about P block elements, mainly the oxo acid, nitric acid and its properties. Oxo acids are those in which the acidic proton is attached to a hydroxyl group, which in turn is attached to an oxo group on the same atom. We have three different oxo acids for nitrogen. One is hyponitrous acid with the formula H2N2O2. Then we have another weak acid which is nitrous acid with the formula HONO. And finally the strong acid nitric acid with the formula HNO3. We have to learn only about nitric acid, which is important among these. The structure of nitric acid consists of two different resonating structures owing to the presence of lone pair on nitrogen and oxygen. Nitric acid with the formula HNO3 is a monobasic acid. Concentrated nitric acid is a powerful oxidizing agent. It oxidizes the hydrogen produced into water, itself getting reduced to different oxides of nitrogen. What are the reactions of nitric acid? Nitric acid reacts with reactive metals except for certain metals like chromium, aluminium, etc., forming their corresponding salt, water and oxides of nitrogen. On the other hand, when it reacts with less reactive metals like copper, you find it forms salt, water and oxides of nitrogen. You find that it shows least reaction with gold and platinum. Any metal, when it reacts with concentrated nitric acid, it forms the metal nitrate, water and nitrogen dioxide. Copper, when it reacts with dilute nitric acid, it will form copper nitrate, water and nitric oxide. Whereas when it is reacting with concentrated nitric acid, it forms copper nitrate, water and nitrogen dioxide. These reactions are the same if we are using silver as well as mercury. Non-metals also react with concentrated nitric acid. It forms its corresponding acid along with water and nitrogen dioxide. In the case of iodine, it gets oxidized to hydriodic acid, which is HiO3. Whereas if you are using carbon, it forms carbonic acid, which further decomposes to produce carbon dioxide and water. Phosphorus, if used, it reacts with concentrated nitric acid, getting oxidized to phosphoric acid with the formula S3PO4. It is nothing but orthophosphoric acid. Now, if sulfur is reacting with concentrated nitric acid, we get sulfuric acid as the product along with nitrogen dioxide and water. Now we shall learn what is brown ring test. So this is a test for confirming the presence of nitrates. When a nitrate salt is treated with freshly prepared ferrous sulfate solution along with a few drops of concentrated sulfuric acid, the following reactions are found to happen. Nitrate NO3-, it reacts with ferrous ions Fe2+ in the presence of H+ ions, forming nitric oxide along with ferric ions and water. These ferric ions bind with water, forming an aqua complex with the formula FeH2O6 times 2+, which further combines with nitrosyl, forming FeH2O5 times NO2+. This is the cause for formation of a brown ring at the junction of the two liquids. So this confirms the presence of nitrate. Along with this brown ring that is formed, the complex formed will also produce some amount of water. What are the uses of nitric acid? You find that nitric acid is used for a variety of nitrogen products. Mainly it is used for making fertilizers and pyrotechnics. The main being ammonium nitrate. Certain explosives like TNT and nitroglycerin is also produced from nitric acid. It is also used for pickling of stainless steel, etching of metals, and it is also found to be used as an oxidizer in rocket fuels. Now coming to the different oxides of nitrogen. Due to its anomalous behavior, nitrogen forms a variety of oxides. First one being N2O, which is otherwise known as dinitrogen oxide. Dinitrogen oxide also has the name laughing gas or nitrous oxide. It is also named as nitrogen 1 oxide. It's a colorless neutral gas and it is prepared by the thermal decomposition of ammonium nitrate. The next compound that we are going to learn is nitrogen monoxide. It is having the formula NO. It can also be written as nitrogen 2 oxide because nitrogen carries +2 oxidation state here. It is also having the name nitric oxide. It's a colorless neutral gas and it is produced when sodium nitrite reacts with ferrous sulfate and sulfuric acid. Next compound that we are going to learn is N2O3, that is dinitrogen trioxide. It is otherwise named as nitrogen 3 oxide. It's a blue colored solid which is acidic in nature and it is produced by mixing nitric oxide with nitrogen dioxide. You know, nitrogen dioxide is a free radical, so it is containing odd electrons in it, due to which it always exists as a dimer, and so nitric oxide, when it combines with N2O4, it forms N2O3. The next compound is nitrogen dioxide. It's a highly reactive gas owing to the presence of an odd electron there. It is a brown colored gas which is acidic in nature and it is produced mainly by the thermal decomposition of lead nitrate. Lead nitrate on thermal decomposition produces lead oxide, nitrogen dioxide and oxygen. The next compound, the last compound that we are going to learn is dinitrogen pentoxide with the formula N2O5. It's a colorless solid having acidic nature. You find that it is formed when nitric acid reacts with phosphorus pentoxide.